to the 5th power. And then we want to find like to yield 2.403 to the 5th power. What would we need?
Yeah, well, these are base 5 and base not any exponents or anything. So it's 2403 base 5.
Sorry, I was saying that wrong.
That's okay, because if we use the word 1,000, we're implying base 10. That's 10 cubed. So we just have to say the digits one at a time when we read a base number. So on 14 for homework 4.2, you're dividing a base 5 number, 2403 base 5, and getting 2.403 base 5. And it works out that when you're dividing like in base 10 or base 5 or whatever base, if you divide by the base number or a power of the base number, then that means you get to move the decimal. Does anybody know what you would have to divide 2403 base 5 by to yield 2.403 base 5? I'll have one of our classmates answer this one. Does anybody know how that worked?
Wouldn't it be 125?
Okay, 125 base 10.
Yes.
Or 1,000 base 5. So either one will work. You're right. Now, why does that work?
So with the different, I guess this is where the powers come into play, where you have, for your chip charts, you have 1s, 5s, 25s, 125. So 5 to the 0, 5 to the 1st, 5 to the 2nd, and it's 5 to the 3rd. So based on those powers of 10, because each power that you go to the left is a decimal point, right?
Mm-hmm. Okay, so I'm showing with my iPad now.
I'm really sorry for the chaos in the background.
Oh, not too bad at all, actually. So we need to do some math operation to get this answer. So we're operate on 2403 base 5, divide, get 2.403 base 5. This was base 10. Okay, so I think we need to just divide by 1,000, right?
Yes.
Yeah. But we're working with base, yeah, so you divide by 1,000, the decimal moves, starts here and it goes 1, 2, 3. Okay. And ends up here. But with base 5, if you're thinking about dividing by 1,000 base 5, then you will get the same answer. Okay, but what we did in our lesson was we divided by the base 10 version, okay, which 1,000 base 5 is 125 base 10, okay, because you have the place values as what was mentioned here, 1s, 5s, 25s, 125s. Okay, so these 1s are the same as 5 to the 0. The 5s are 5 to the 1. 25s are 5 squared. 125s are 5 cubed. Okay, so 5 cubed, the base cubed is the same as, 1,000, which is 10 cubed, or 1,000 base 5, which is 10 base 5 cubed. Okay, so those are all the same value, like the same structure, not the same value, but they're the same structure because you're cubing the base. And when you divide by a power of the base, then you just move the decimal point over. So what we did in our class was we did two, 4, we modeled this, well, 0, 3. Okay, so we modeled that and we wanted to put them into groups of 125, but right here we don't have any. So we need to put these over here and make 5 of them each. The exchanging, okay? And then we don't have any 125s here. So we have to like exchange all of these here into the 5 places for doing 5 of each of those. But that gets too cumbersome. And so what you do end up having is that you end up having, yeah, and then all of these went over to here, and there's lots of groups of 5. Okay. It's a little bit abstract because I can't draw them all out. But in the ones place, you can get 2 groups of 125 because that's right here. We know that that's true. Okay, so we can get 2 groups at least. But with the leftovers, we have to go to the next place down, which is the 1/5 place, or 5 to the negative 1. And you put all of the lots of groups over here. Even more. You get 4 groups of 125. And so on. Now, if you want to see this process, my recommendation is go back to the lesson video or the notes, class notes, to see how that worked. But when you're dividing, the overall takeaway is that when you're dividing by a power of the base, you just move the decimal point to the left that many places. Okay, so if you had to move the decimal to the left 3 places, like here, then you're dividing by 1,000. Base 5, sorry, right here. I don't know if does that help? Okay, any other questions? Okay. All right, so we're going to do some mental math today. And if you do have more questions, you can feel free to email me. We're gonna do mental math today with division. So this is kind of a fun lesson. Before we get started on that though, I'm going to take attendance. Okay, so I'm going to share my iPad here. So in this class, we'll go over I have 5 strategies for dividing numbers mentally. 5 strategies. And we'll start with the one that we use the most, which is called rearranging. Which I'm not sure why they call it that in the book, but what it essentially is it's called, I call it back distribution. We've been doing this before with some of our 30-second challenges. Okay, so what you do to execute the rearranging strategy is you do back distribution of division. So we're using the distributive property. Okay, so put distributive property. So it's back distribution to division over addition or subtraction. Okay, and this is the one that we use most often when we divide mentally. So we're going to do an example of 91 divided by 7. Okay, so we want to divide 91 by 7. This method, we break up the 91 into a sum or difference of two numbers and divide each by 7. So behind ideas, initial thoughts about what I can break up 91 into to make it the division by 7 easy.
Well, 7 times 12 is 84, so that's close to it.
Okay, so I break up my 91 into 84 and the difference of 84 and 91. So what's the difference between 84 and 91?
7.
Good. Okay, so I take that 84, the 91, break it up into 84 and 7. Because you remember, now when you break these numbers up, you can do it in a number of ways. Okay, so any of these will work. Some people probably have other thoughts too. We can take a second approach as well. You said that 84 divided by 7 was then going to be next. Okay. And that's 12 plus 1. We get 13. Okay. When we are in this homework, you're going to do some mental math problems. But even though this stuff is done in your head on the homework and then the test, I can't know what's going on in your head, so you have to kind of write it down. And as we've been doing before, I think I mentioned this before, when we're doing mental math, we want to write down the problem here, set it equal to the first step in our process to solve it, and then every subsequent step will be written under with equal signs. Okay? You have to make sure they're all equal. And any questions on that? It is actually in this section from the book when you do the reading for the homework where they describe that at the end. Okay, so to illustrate mental math. Now, what I do when I do mental math, I like to put down the property that I use. So this is the distributive property. If I ever use distributive, commutative, or associative, put those down. Or if I give a clue to my mental math approach, you can write that down, as I'll demonstrate in another problem. Okay, great approach. Does anybody have any other approaches to this problem? Any other ways to solve it? What else can we do? How else can we break 91 into two numbers that divide by 7 nicely? It's good to have easy numbers. You go easy as possible since it's mental math.
You could do 49 and 42.
Okay, 49 is 42. Okay, great. So I distribute this 7 to the 49 and the 42 by the back. good. All right, so for time's sake, I'll go ahead and show you one that I was fishing for. But all of these are good. There's like no wrong way to do this for sure. Not unless you get the answer wrong, but the process, if your process is good, then your answer is good. So 91 divided by 7 can be also separated into 70 plus 21. Okay. Distribute the 7 here again. All right. So that's back distribution. We know we've done this before in our class with the 30-second challenges. Now, what we do in multiplication a lot is we do front distribution. So here's a question. And I'm going to show you what front distribution is. Multiplication. We can take an example of 3 times 12. We can say that that's the same as 3 times, I broke the 12 up into 10 plus 2. Okay. When I distribute my 3 to the 10 and 3 to the 2, I get 3 times 10 plus 3 times 2 equals 30 plus 6 equals 36. Okay. That's the example of front distribution, where you're taking the number and you're distributing it in the front to the numbers in the back, the sum in the back. Okay. Does this work with division? And if you find one counterexample, then that means that it's sufficient to break the rule for everything. Can we use front distribution with division? Okay. Does anybody have any initial thoughts? Let's say, let me give you an example here. I do 12 divided by 10, and I'm breaking up my 10 into 6 plus 4 because I know that by distributing the 12 to the 6 and the 12 to the 4, this is a question, so I'm going to put this right here. Put it in red. Will that work? Here's where my front distribution happens. 12 divided by 6 plus 12 divided by 4. Okay, are these equal? 12 divided by 10, 12 divided by 6 plus 12 divided by 4. What do you guys think? Nicole's shaking her head. Anybody?
No, because if you do it, it's 3 plus 2, and that equals 5, and 12 divided by 10 is definitely not 5.
Right. So this is a good counterexample, sufficient to disprove this idea. Division is not, you can't distribute division by the front. You can only do it in the back. Multiplication you can do both ways because of the commutative property, really. So we know that 12 divided by 10 is 1.2. And we know that, I'm put my question mark here, I'm not sure still. 12 divided by 6 was 2, 12 divided by 4 is 3. And 1.2 is definitely not equal to 5. Okay. Thus we cannot distribute division in the front. Okay, so there's a little aside. And going back to our actual strategy, you break up the 91 into 2 parts. No, we got 3 ways that we can break it up into a sum. Sometimes it's sorry, not easier, but like sometimes you can think about breaking the number into a difference. So I have my next example is 920 divided by 8. Okay. Breaking 920 up into a difference, we can do this, where both of the numbers are divisible by 8. So here's one way of doing it. Let me know what 1000 divided by 8 is. Kind of leads into another strategy for dividing. Do you remember the multiplication strategy for multiplying by 8? Somebody remember that multiplication strategy? Division by 8 is similar, but we won't specifically cover that number. What do you guys do when you multiply by 8? What's the mental strategy on that one?
Counting with our hands.
Okay. Well, we can't quite do that with our 1000 divided by 8. Well, maybe we can.
Could we break it up?
So 8, yeah, we'll break up the 8. So if you do that, you break the 8 up into 2 times 2 times 2 times 2. But what you're really doing is that you're having 8 3 times. Okay, having the 1000 3 times. I mean. So hold on, let me try it this way. So what we're thinking about is 1000 divided by 8. Which means I'm going to take 1000 divided by 2 3 times. So the first time is 500. Now we're going to do the second time, and then the third time. Second time we get 250, the third time we get 125. Okay? So if you take a number and you want to divide by 8, you half it 3 times. So those are similar to a couple of things that we'll do in the other strategies. So we know that 1000 divided by 8 is 125. $80 divided by 8 is 10. So we got 115. Did anybody think of another way to divide 920 divided by 8? That's okay. So we'll go ahead and move on. But there's probably a lot of other ways you can do it, using subtraction or even addition. So that is rearranging. You can break up the number, the dividend, the total into two numbers, and then use back distribution of division over addition or subtraction. The next way is called compensation. Right. And we've done compensation with subtraction and addition. With compensation, you can multiply or divide the dividend and divisor, the two numbers in the problem, by the same number. Because of equivalent fractions. Okay. So with subtraction, division is like repeated subtraction in some ways. And you can, remember, you can add the same number to each part of the subtraction problem, or you can subtract off the same number. That's compensation. You can also do that with division. You can multiply the division problem by the same number, each number in there. And then you can also divide each number of the division problem by the same number as well, and maintain the ratio. That's because of fractions. And I'll show you here. We're going to do an example. 4,000 divided by 250. Okay, so the answer is not immediate, probably for a lot of you. And so we can use multiplication or division by the same value to maintain the ratio, and we can get this, and we can get the answer. So what number should I multiply or divide these two by, and to make the problem easier?
You could divide them by 100.
Okay, great. Let's go ahead and divide them by 100. What would I get for my problem, my new problem? What's 4,000 divided by 100?
40.
250?
That would be 2.5, huh?
Hmm.
Maybe that wouldn't be as easy. I don't know.
What do you guys think? Should we try a different number or see what happens here? Yeah, this is trickier because that's 2.5.
Yeah, maybe just divide them by 10 so that it's not a decimal, I guess. I don't know.
Yeah, let's take a look. 400 divided by 25. And we'll do a mental math strategy with 25s as well. But right now we don't know that one yet. But 25s are not bad because of money. We work with money. Okay, so I've written my problem here. I've written my first step here, and then every subsequent step is going to go under on that side. So make sure you guys do that in your homework. Can anybody tell me what 400 divided by 25 is? You might be able to do the strategy we did before with rearranging to help you, or maybe you know money well enough that you can just say, oh,
Well, since we know that 25 times 4 is 100, Then we could do 100 times 4, so that would be 4 times 4 is 16.
Okay, 16. Good. So there's 4 25s into 100, and then there's 400s in there. Interesting. Let's see. Okay. We broke up the 4 into 4 times 100. And then we go 4 times 100 divided by 25. That's the same as 4 times 4, which is 16. Now, what property did I use to go from here to here?
Associative.
Yep, associated property. Okay, good. All right. So that's compensation. Going to our next one. Yeah, I have just another example here. If I have, because yeah, what we did there, yeah, and I wrote down here in my notes that this one right here was divide by 10, divide both by 10. Okay. So just so you know what happened. You can also multiply, you can divide. I wanted to show you the multiplication one. If I multiply both of them by 4, I get 16,000 times 1, or sorry, not times, divide by 1,000. Okay, so this one was a multiply by 4. Okay. And I can do this division pretty easily. 16,000 divided by 1,000 is 16. Okay. So there's a couple ways of doing that one. Next one is 900 divided by 60. Okay. Any thoughts about how I should approach that one using compensation? Compensation again is multiplying or dividing both numbers. Oh,
What about like dividing by 30? Dividing both by 30.
all right, so what do you get? I'm gonna pull this down because I forgot a thought, or I wanted to share a thought for about another one. What do you do when you divide by 30? What do you get for your new problem?
30 divided by 2.
Nice, make it easy. 15. So what I did was I divided each by 30. Divided both, not you, but not me, but you guys did. By 30. Okay. All right, so why does this work? So I mentioned before equivalent fractions. And for this first example, let me do a short part. First example, we did 4,000 divided by 250, which you can write as a fraction if you go like this. Now we made it into, this first one we made into 400. Divided by 25. Okay. And you can do that from dividing the numerator and denominator by 10 over 10, or sort of dividing the problem by 10 over 10. Okay. So that's one way that you did the equivalent fractions. Yeah, and then the other way was where we took, the 4,000 divided by 250 and multiplied it by 4. You got 16,000 divided by 1,000. Okay. So those are why they work. You can, why compensation works. It's just finding equivalent fractions. Okay. So, and you can do that with any division. So with this one, we did 900 over 60 divided by 30. And then now you have a simpler problem, just 30 divided by 2. They have the same answer, the same ratio, because they're equivalent fractions. All right, so let's divide by a couple of numbers, kind of like multiplication facts where you did some strategies. We're going to divide by 4 now. If you want to divide by 4, what's the analogy to multiplying by 4? What do we do when you multiply by 4?
Double the double.
Yeah, double the double. So what we're going to do is we're going to do half twice, half of the half. Okay, so that's my strategy. If you want to divide anything by 4, take half of it twice. It's kind of like to divide by 8, take half of it 3 times. But a lot of times we come by 4. So our example is like 96 divided by 4. What is 96 divided by 4 using this strategy?
You do 96 divided by 2.
Yeah, what do you get when you do that?
Well, it's 48, isn't it?
Good. Okay. And we divide that by 2, you get 24. So we divide it by 2 twice. All right, so that's a nice one there. Let's do one more. If I have 50 divided by 4, and I know that 4 doesn't go into 50 evenly, but I can use the divide by 2 twice to help me get the decimal. So what is 50 divided by 4 if you use this strategy?
Fifty divided by 2.
Yeah, and that is what?
25. And you divide that by 2, and it's 12.5.
Good. Nice. Okay, so let's divide by 4. The book also covers dividing by 5 using this strategy. Now, does anybody remember the multiplication by 5 strategy that the book introduced us to? wanted to multiply something by 5, what would I do? Let's say, what's a strategy for like 25 times 5?
Wouldn't you multiply it by 10 and then do half of that?
Yeah, so what you're doing is, yeah, they said take half of the number and then multiply by 10. Let me do an even number just for fun. So if we did 24 times 5, half of that is 12 times 10, which is 120. This dividing by 5 is similar. When you divide by 5, you divide by 10 and then double that. Okay. Let's do an example of something divided by 5 that's not like easily calculated. Come on. Let's do, well, actually, I wanted to see why that worked first. Okay, so the example is 20 divided by 5. You divide by 10, you get 2. You double that, and you get 4. So according to the strategy. Now my question is, why does this work? Okay. Why does this work? For example, if you have something like a divided by 5. Why does this work? Well, I kind of like fishing for a proof thing. Let's, for time's sake, let's go ahead and just move on. When you do these, this is kind of like a math trick. You want to have the students know why your math tricks work if you do ever share any with them. Mental math. So what I did to think about this one is I used the fraction approach, that some number divided by 5 is the same as that number over 5 as a fraction. And then what I needed to do was I needed to divide by 10 somehow. So I take my number and divide by 10, which means I'm going to say a divided by 10. And I can't just put in a divide by 10. I need to compensate for it. So I need to do a times 10. So I still have my 5 under there. I can divide and multiply by 10. That doesn't change anything, right? So I'm going to kind of take this one right here and put these together as a fraction. That's the same thing as a divided by 10. Oh, come on. Sorry about that. Times 2. Or times 10 over 5. Okay. So that makes it a nice, easy strategy. You take, if you want to divide by 5, you divide by 10 and then times 2. We divide by 10 because that's easy to do in base 10 numbers, which is what we use. So here's another example. What we're going to do. 625 divided by 5. Okay, so if we want to do 625 divided by 5 using this strategy, how can we do it?
My first thought is to just do it divided by 10 and then double. So it would be 62.5 times 2, which that's not the easiest way maybe, but that's just what I
No.
first see.
Yeah, no, that's exactly what I wanted you to do. Is I wanted you to solve it that way using this strategy where you divide by 10 times by 2. Now this one is not the easiest number to double, but let's use some mental math to do it. I can split up the number into easier parts, multiply those parts by 2. That I use the distributive property here. So what I have is 60 times 2 and 2.5 times 2. That's a little bit easier, right? That makes 120. And 2.5 times 2 is just 5. We get 125. Okay. All right, so that's, let's see. Let's do another one for fun. Okay, let's have you guys generate this one. What number am I going to divide by 5? Now, what numbers are divisible by 5 evenly? Or even doesn't matter because we got decimals available to us. So let's have you guys throw out a number. What's your guys' favorite number? That's like in the hundreds or something.
$615.
615. Okay, so we know that that's just 2 groups less than 125. That's 123. Let's change it
Didn't even think about that.
to, so sorry, it's 20 groups less. So it would be 4 minus 4. Let's do like 515. Okay, what does our strategy say to do now? Oh, see, that's gonna be another easier one. Let's do the 425. That's 200 groups less.
How about 805?
Yeah, let's do 805. Okay. Now we're going to do it where we divide by 10 and then double it. So what would be the answer to this one?
80.5 times 2.
Okay, so we divide by 10. Okay, and then what's 80.5 times 2?
So, let's see, 80 and 80 is 160, 161,
Right.
right?
You broke up the 80.5 into 80 plus 0.5, or 5/10.
Yes.
And what you did was use distribution from the back of multiplication over addition. And then you did 160. Oops. Go ahead and show this part. 80 times 2. And then now you did 160 plus 1. Okay, good. 161. All right, so I think you guys are getting that one. The last one that we're going to do is dividing by 25. Mental math. Okay. And the rule is divide by 100 and then multiply by 4. So I have this example of $200 divided by 25. Okay, does anybody know how many 25s are in 200 anyway? or like money or something.
Eight.
Yeah, there's 8 of them. Our strategy says to divide by 100, so take that 200, divide by 100, and then multiply by 4. Okay, so that becomes 2 times 4, which is 8. All right. Now, what we did above here was we did a little bit of a proof here. Why does this one work? Similar to that one. Okay, why does that one work? While you guys are thinking on that, I'm going to plug my computer in. And you guys come up with a little proof or line of reasoning, kind of like what we did before. So one thing we can do is get started. So I have some number A and divide by 25. Okay. So why does this work? I need to show dividing by 100 multiplying by 4 to be equivalent to divide by 25. Did you guys copy down your notes the proof for the other one? Why it works? Scroll back up here. Why does this work? All I'm doing differently is I'm putting 25 there, and then we have to see how it plays out. The approach is still the same. Okay, guys are super quiet on this one. But let's go ahead and move on for time's sake. And we're going to say, okay, A divided by 25. We want to divide by 100. So we're going to take our A and put over 25, use fractions to help us. If we want to divide by 100, we need to multiply by 100, put that over 25. Now we chose 100 here. You can use any number if you want, but you chose 100 because when you divide by 25, this part right here will work out nicely. So we take our number, divide by 100, and then multiply by 4, or multiply by 100 over 25, which is the same as a divided by 100 times 4. Okay, so that's why the process works there. So we're going to do another example here. Our last example. $775 divided by 25. Now I just pick a random number to divide by 25 by. And so we might work with some decimals, but that's okay because we got some good strategies for multiplication. All right, how do you guys solve this one? Okay. Yeah, let me go ahead and demonstrate this one. Then I'll have you guys do some group work here for the last 10 minutes. This one you divide by 100, which gives you 775 with the decimal moved over 2 spots. Okay, you know that strategy. Multiply that by 4. You can always double the double if you want, or you can break it up into 7 plus 0.75 times 4, and then we distribute the 4. Seven times 4 plus 0.75 times 4. And you can do the 28 here if you want, and then we just need to break up the 7.75 times 4, because that's how I thought about it. And use the distributive property again. 28 plus 0.7 times 4 plus 0.05 times 4. And that's 28 plus 2.8 plus 0.2, 0.2, which is equal to 28 plus 3 using the associative property at 31. All right, so we have 7 minutes. I'm going to set up some random groups. What I want you guys to do is just come up with a divide by 5, and if you have time, divide by 25 examples. And then we can share. So we'll do some breakout rooms. 7, 3 to 4. Let's do 3 to 4. Book the room. Open all the rooms. Okay. Your job is to think of your own, divide by 5 and divide by 25, and then share, and then have your partners solve them.
Oh. Are we supposed to come up with a problem all together, Mr. B?
Yeah.
Okay.
Well, you can come up with one and quiz your group mates on it too. You can do that.
Okay.
Might be kind of harder to do that together. Yeah.
That makes sense. Thank you.
Meredy, are you available to go to a breakout room? So what are you guys thinking? Anybody have a problem for divide by 5?
Yeah, so we were doing 500 divided by 5. And so I think that would be, if you did 500 divided by 10, that's 50. And if you double 50, that gives you 100.
Good, good. Try one that's a little bit harder because you can do that one easier. Like 500 divided by 5 is 100. Try a harder one and see how smoothly it goes.
Sounds good. Yeah, I definitely went for the easiest one.
That's fine.
All by myself. I'm glad to see I have people.
Yeah, I moved you, Nicole, up to this group.
Thank you.
Mhm. So Shelby and Lindsay, did you guys come up with anything?
I didn't hear anything from Lindsay. Are you there, Lindsay?
I'm here, yep.
Oh, okay. I guess you must not have heard me at the beginning.
Oh,
So
shoot, I
just-
didn't. Sorry.
No, my bad. I made a problem. I did 665 divided by 5.
Oh, great.
I-
Using mental
I'm still
math,
working
answer on
through
that one.
mine.
Oh, did you come up with one?
I'm still working through it, so I'll do that. If you don't mind, I'll do that one and then solve it. And yeah.
Yeah, go ahead
Okay.
and solve that one.
Did you want me to walk through it? Sorry.
Yeah.
Oh, okay. So I divided it by 10, which is 66.5, times it by 2. Break up the 66.5 into 60 plus 6.5. And then using the distributive property, I multiplied 60 times 2 plus 6.5 times 2, which came out to be 120 plus 13, which equals 133.
133, yeah. Sounds good.
Sorry, can you just step back one step? How did you get the 120? I'm
60 times 2.
from the, oh, okay, I see.
Sorry, did you need me to go back further?
Nope, no, that's great. Thank you so much. I see how you got the 60, so that, yeah, thank you.
Yeah.
All right, good job. We'll go ahead and come back to the class since our time is up.
Okay.
Okay, welcome back, everyone. Looks like that we're at time now, so Feel free to take off. Does anybody have any questions though? I can stick around for a few more minutes if you guys do, but otherwise, have a great Monday.
Thank you.
Mhm.
Thank you. You too.
Hopefully you get good practice. You're welcome.
Dr. B, I'm so sorry. I had to come to class a little bit late. My Zoom wasn't working. I just didn't know if I had missed attendance or not.
Yeah, you did. So, oh no, you didn't. I got your name down. Yeah.
All right.
Got it.
Thank you. Appreciate it.
You're welcome. Have a good day.
Have a good one.
Dr. B,
Yeah,
can I ask you a question about Friday's lesson?
there isn't one.
Last week, sorry.
Oh, okay.
Sorry, I didn't
Sure.
clarify that. So I went back because I came on late and missed the first part of class on Friday. And when I was watching the video, we had done the division kind of 2 different ways. And I just want to know like how to know when to do each one. So
Oh yeah. I don't know when to do each one. Okay.
yeah, so here we broke it up into how many were
Oh.
in each group.
Yeah. So for that one, just so you know, you can do either one. I just did it a couple ways, just to show that there are 2 ways following the both perspectives of division. So either way
Okay.
you want to do is fine. You can choose one way through the whole homework, or do both intermittently, or whatever.
Okay, because I was like, how do I know which one to do? So okay, that answers my question.
Yeah. good
Thank
question.
you. Okay, I think that was it.
All right. Have a good day.
Okay, thanks, you too.
Bye.
Bye-bye.